Okay, good day. So today we will be discussing about different engine condition monitoring evaluation system. So what are the different engine condition monitoring and evaluation system that we can use on our main engines? So these are these are just some of the engine condition monitoring and evaluation system. So there are so many systems that we are using on ships, and different engines have different systems. So we will just pinpoint some of this engine condition monitoring and evaluation system. First, okay, we have these are the different engine condition monitoring and evaluation system. We have the bearing wear monitoring system, crosshead and crank temperature monitoring, cylinder liner monitoring system, mean bearing temperature sensor, torque and power measurement for rotating shaft, engine performance system, and water in oil sensor. So these are um, also the engine has temperature and pressure sensors also all over the engines. So these are just hand-picked engine condition monitoring and evaluation systems used. Okay, first we have the bearing wear monitoring system, BWCM. Measures and displays the combined physical wear of crosshead, crank, and main bearings, providing early bearing seizure warnings if problems occur during engine operation. So we have a PC working station in here, and then we have a cabinet with dual segment process controller and power supply. And then there is a crosshead bearing, crankhead bearing, and main bearing. There is a monitoring system on those parts of the engine. So the sensors are specifically designed to provide reliable and accurate measurements over years of operation inside the engine. So the main bearing temperature sensors So the main bearing temperature sensors can be fitted into any type of two-stroke diesel engines. The sensors are mounted on the main bearing girder with the tip of the sensor in direct contact with the bearing shell. So the sensor measures the combined temperature of the bearing shell and of the lubrication oil that flows from the bearing. So temperature sensor mounted on the main bearing girder. So this one. Okay. So we don't have another picture in here. Okay, that's it. Next, we have the engine performance system. The engine performance concept enables permanent online monitoring and diagnosis of propulsion auxiliary engines for two-stroke and four-stroke engines, and forms the basis for condition-based maintenance. So the system normally equips the main engine with fixed online combustion pressure sensors, while a portable offline combustion pressure sensor is employed for each auxiliary engine. So this is the advanced power indicators, yeah, because we can sense the combustion pressure in here. So these advanced power indicators, or what we call is the engine indicators. So advantages: the benefits of the engine performance monitoring system include reduction of fuel consumption, monitoring of cylinder load, calculation of CO2, NOx, and SOx, reduction of maintenance costs and improved planning of maintenance, reduced risk for engine damage. So that's it for the engine performance system. Next, for the shaft power meter. So torque and power measurement system for rotating shafts. So the system allows the ship's management to maintain or increase the speed while saving significant amounts of fuel, reducing CO2 and NOx output levels. So we have a meta power mimic. In here we have processing unit, and then we have a control box, and then you put a ring in our rotating shaft. So it measures torque and power transfer from the main engines to the propellers. Comparison between power output and fuel consumption gives valuable information, avoiding overstressing of the engine. So the system measures the RPM. The shaft power meter is a digital measuring system using a laser beam from ship's main engine to propeller system. Next, system measures the RPM, torque, and power transferred from a ship's main engine to the propellers. And then shaft power meter is a digital measuring system using a laser beam for detection of shaft torque, shaft RPM, and consequently the transferred power. So the system offers high accuracy and good long-term stability by transmitting measured data via satellite from the ship to shore. The shipping company's operation management is able to decide the most economical operating modes for the ship's engine and propulsion system. Okay, next we will go to crosshead and crank temperature monitoring. So the wireless bearing temperature monitoring system is capable of continuously measuring the metal temperature of bearings during engine operation. So this is wireless. So there is a sensor in here that will pick up the temperature in the other side. So this is a wireless bearing sensor and antenna. So usually it is put in here beside the crosshead and crank. So this one is our bearing sensor, and this one is the antenna. There's a wire in here going to our engine, to our control module or engine control room. So each sensor is individually interrogated from a multiplex signal processing unit using a high frequency and low energy radar pulse. So the radar pulse is transmitted to the wireless sensor via a coaxial cable to a stationary antenna positioned inside the crankcase. So this is the sensor, and then there is a radar pulse from signal processing unit and pulse response from sensor. So there is a feedback, and then the stationary antenna will convert that into the signal processing unit and then sent to the shore or to our engine control room. Within the interrogation range of the stationary antenna, the sensor responds to the radar pulse by reflecting a pulse pattern back to the signal processing unit. So the characteristics of the reflected pulse is uniquely defined by the temperature. The radar pulse from signal, okay. So what are the main components? Wireless temperature sensor, stationary reading antenna, and signal processing unit. So next we have water in oil sensor or detector. So the UMICAP moisture and temperature transmitter series for oil MMT330 enables fast and reliable detection of moisture or water in oil. So the MMT330 can be used in online moisture monitoring and as a control device allowing separators and oil dryers to be separated only when needed. So fast and reliable detection of moisture, water in oil. Proper monitoring saves both oil and the environment. With the MMT330, it is easy and economical to monitor the effects of moisture in oil. So those are the different engine condition monitoring evaluation systems added on our ships for engines. So in this way we can monitor the condition of our engine, and then we can make predictive maintenance. We can make a maintenance before an actual damage is happened. So thank you. I hope you have learned another new set of information. So I'll please do like and subscribe our video and share it to your friends. So thank you very much. God bless and see you on our next video. Bye.